Good morning. Today is July 8th, 2017, and this is the John Chappell Natural Philosophy Society Saturday morning science chat. So we have been discussing issues around atoms, and 2 weeks ago we discussed, the
Franklin,
evidence.
before you start,
yes,
I didn't see a message, email message of the meeting today.
Yeah, I didn't send one out today, not yet anyways. Just one on Thursday. I figured that was soon enough.
So you're not sending one out?
Not this morning, no.
Okay.
Seems that people seem to find it, whether I send that one out or not. We have our small set of dedicated people who come to this every week. Okay, so as I was saying, and then last week we looked at what evidence they have about atomic data, and this week I thought we'd actually try and get into some specific atomic models from some of our members. And so this week I think we will concentrate on something that Slobodan has been working on. Aetherodyamics. He has translated 2 papers from the original Russian, and let me put that up, and then I will let Slobodan take it away. He's translated chapters 6 and 7 for us, and I'm going to hand the conference over to Slobodan. So go ahead, Slobodan.
Okay, thank you. So just want to be sure. Now I see only part of the screen. I wonder if maybe those, squares with the participants' names and so could be moved, removed, or whatever, so that I would maybe.
Well, I think if you below the participants, at least on my screen, there's like 5 little dots.
Okay, good.
And if you pull, and you can grab that bar and you can make that screen smaller.
Yeah, okay. So
and I would advise everyone else do that so you can see the page that Slobodan is showing as much as possible.
Okay then. I thank you for this opportunity. I mean, and it was good actually that the discussions on vast chat were about atom structures, and then the questions in the email were raised about the issues with the modeling of the helium atom, actually of the alpha particle, and so on. So I took some time to translate parts of these 2 sections in the book of the Atsukovsky with the name, I say, Aetherodynamics or Aetherodyamics, whatever. During last year or so, on different occasions, I also was prompted to translate some other sections when it came to the nature of electromagnetic waves, the structure of photon, the mechanism of gravity, and so on and so on. I was trying to convey some basic moments there, and in the discussions, in the email correspondence, and so on. So now maybe if I try to walk you over these 2 sections relatively quickly, and maybe later discuss on some particular topics and so on, it will be more clear what actually the aerodynamics could be. Let me start here. So here in this sections that is devoted to photon, the author starts up front from where those protons would actually come. And somehow, as all of fluids or gas media are supposed to have some particles that are kind of elements of those media. And then actually in the Aetherodyamics, Atsukovsky has started from the very, very tiny particles that move in all directions, and that medium has particular parameters that have been communicated on a couple of occasions earlier. Here, when it comes to the proton, he starts from actually protons coming out of the center of spiral galaxies, and somehow there might be also kind of answer the question or be related to the discussions about black holes and things like that. Anyway, he comes here to suggest that he would have those structures formatted in the process of collisions of those flows of ether on the large scales of the reality, in particular on the centers of the spiral galaxies. And you may follow, I mean, kind of text to the extent it would be possible, but I would move the cursor now to the particular form of those structures. One of them is the proton. The author starts from just obvious things like if one takes a drop of what was the name of this liquid?
So I think, Slobodan, it's important. So the main particle in ether dynamics is the proton.
No. It's not made proton. It's so-called amer. Amer, something like plankton, or we could give different names to it. The point is actually that the small size, high speed, the medium has a pretty, how say, relatively high density in relative sense. But again, those are topics that I would not go into details now. There is a table with those parameters, and those parameters are kind of, how say, related to all the aspects of this, say, theory or this approach. So maybe I could answer questions of the kind, maybe not that detailed, but if I would be having the how say the table here, we could go pinpoint to whatever parameter, but some of those parameters would be visible here in this text. Okay, this is kind of phenomenologically how it proceeds when drops of. Could you help me? What is the name of this liquid used to put into the?
Well, it looks like you have a picture of some drops coming down.
Yeah, drops of how say. The tool for writing, you put some liquid into it and then you write, right? Ink. Yeah.
Ink.
Drop of ink into the water, and one can follow such a how say process of those drops being reformed into the vortexes, toroidal vortexes. It's kind of maybe the closest picture of it is or maybe mechanism or something to be visualized is kind of the smoker's ring, the tobacco ring, the ring that the smokers can produce by putting the air out of lungs and so on. So here is just something like qualitatively. So here I go now directly to the kind of
I don't hear a thing.
Here we go. Franklin, did you give me control? Okay, here, yeah. There's some kind of slowdown here, maybe on my network. Oh, here. Perfect. So there is nothing before that, I guess? No. Here, it's shown that form, kind of that toroidal vortex form. can you see here two cross sections, right? One is the kind of vertical cross section on the left side, and the horizontal cross section on the right hand side. And these diagrams show the distribution of density, distribution of temperature, and on the right hand side, distributions of velocities of movement of those ether particles along the toroidal directions. That means kind of meridional, how to say, upper part and the lower part, the velocities around the structure, like equatorial or ring. So toroidal and ring are two motions on and within such structure. That's very important to kind of visualize and kind of understand. So distributions, as I said, of density are here. Distribution of temperature is here, and velocity in toroidal direction. That is out of here, out of the center and around back into the center, and at the same time around equatorial. That means here. So this is the velocity of the equatorial movement, and this of toroidal movement. Okay. Let me see what would be the next. So he shows here the, how say, he arrives at these sizes of the structures, different parameters. Oh. It's amazing, really, kind of throughout all the book, how he really calculates everything, just say, kind of from scratch, combining existing results from particle mechanics, quantum mechanics, and so on, and the theoretical expressions and so on. So here are kind of what would be maybe interesting here to see would be what is the volume here. This equation 6.3. Can I move this? I have problem here with the this bar for the size. It's too close to the scrolling. How to say?
Do you want to make it smaller or larger?
Maybe I can do it, but you know, when I scroll down up, when I scroll down, actually this field with this bar is too close to it. Can be moved? Can this bar be moved a little bit to the center?
I don't know. Which bar are you talking about?
This here. Okay, I mean the bar for the sizing up and down. I mean zooming in and zooming out.
What about it?
Okay, it's close. It's too close to the button where I scroll down. Okay, but I can scroll down. Okay, I will try to scroll down by the okay, by my mouse. So here's the volume of the proton. Here is the density of the proton. Right? What's the density? Yes. So all the parameters are here. One can compare maybe based on his insights and knowledge and so on. In the process of kind of determining those parameters, it has been used the known, how say, data about the magnetic moment of the proton. And what is important here would be to understand and to kind of accept or think about it. That actually here in gaseous media, as ether appears to be, the flow that are counter to each other are actually be getting attracted, and those that are co-directional are being how say repulsed. That actually is related to the gradient of velocity, and then increase or decrease of the pressure. So when the velocities are in opposite directions, the flows are in opposite directions, there is increase of the gradient of velocity and means a decrease of pressure. So pressure in that area is decreased compared to the environmental pressure. So those structures, those flows are then be pushed toward each other. And on the other hand, if those flows are co-directional, the gradient of velocity is decreased, and then the pressure is increased, becomes higher than in the environmental media, and then those structures be separated out of each other. So based on those very basic mechanisms, all those considerations here are being conducted, and the parameters arrived it and everything. I mean, in general, the theory is very consistent in my view. So here, I mean, just to get back a little bit, I mean, the mechanism of the how to say magnetic momentum is shown here in this figure. So we have here magnetic field, external magnetic field. We have this proton being here now in horizontal position regarding to its how to say axis of symmetry, the only axis of symmetry, because actually those parts are not symmetrical as has been shown here. I mean, maybe on previous slides. And then if we here compare here the directions of flows of external field of the flows within the structure of proton, we can see here that the kind of momentum torque has been created that actually tends to push the electron, the proton, so that its main axis gets, you know, from here shifted by 90 degrees and gets parallel with the fields of magnetic induction. And so actually that we have kind of opposite flows of external and internal fields, or external and internal flows of ether. I may not have, you know, enough kind of oversight of the content of those pages, so I will go over. Maybe if you may want to for me to get back to some particular part or what, wherever I can go back. But here, just not to forget that actually the magnetic field. Get me back here to this. Oh. The magnetic field is actually related to the flow which goes out of the central canal to the periphery, that goes toroidally. So the velocity, density, the velocities of those, how to say, flows is perceived and kind of experienced as a magnetic field. And the impact of flows that goes around, like a ring-like or circularly, those are related to the electric field. And I would now use the opportunity to mention that the electric field, how to say, gets attenuated, or the impact or the flows, the velocities and so on, get reduced by 1 over r to the second degree, and the velocities and flows that are related to the magnetic field, the toroidal motion, internal motion, I mean kind of or distributed motion, is related to the magnetic field that decrease with distance as 1 over r to the third degree. So let me see what we do here next. Okay, we have covered that. Just explaining what is the electric field, what is the magnetic field of proton, and what is the electric field of the proton. Okay, here there was a question about what are the particles of the ether. So those are here are those armors. For example, the parameters here: number of armors in unit of volume of the proton. It amounts to, look this, 10 to 131, and then the average length of rerun of an AMER, maybe in English, if you would spell, it would be AMER, right? In the body of a proton, it turns out to be this long or this short. And then the body temperature of nucleon is pretty low, 10 to minus 75 Kelvin. The average speed of the thermal motion of an AMER in the body of nucleon comes like this, relatively high. So, I mean, it's very important to have this in mind, that the higher density of the structures becomes, then the lower temperature of that very structure, again, like is, right? And with temperature is very important, because with the increase of temperature, the viscosity of generally gas fluid is increasing and so on. That was mentioned in the email, for example, today by Carl Littmann. Both the rarefied gas, or rarefied medium, as ether substrate, as Newton even had conjectured, on the one hand, and the other, the viscosity, depending on temperature differently than the general liquids have a dependence on. So I put here some part in Russian, you know, if somebody would like maybe to have something explained. But generally, you know, everything what happens based on the gradient of pressure, density, temperature, and so on. So I would not go here into those details, but you would see here that really all the parts, everything has been kind of pretty much, how to say, consistently and kind of exhaustively, how to say, in depth analyzed and visualized. Here is the situation. What would be the mechanism of attraction repulsion of such two structures, say two protons that will come next to each other? So as I said before, the forces of attraction, depending on distance, are 1 over r squared and 1 over r to the third degree for motions that are for the ring part, or circular, or equatorial, and the one that relates to the toroidal.
Well, is it 1 over r squared or 1 over r cubed? I mean, there's a big difference between those two.
Yeah. But look, even Bill Lucas mentioned something, third degree of r, 1 over r to the third, something that was very important for modeling of the nucleus of hydrogen, that means alpha particle. You will see later, this kind of some, just in the introduction, you will see later, very soon comes to the structure of neutron, and after that the structure of deuterium, and then up to the helium. And those aspects of electric charge, electric momentum are very important there. And you will see how actually that kind of dynamical equilibrium leads to those structures in a very consistent way regarding those magic numbers, in particular, that we touched on at last Saturday's chat. So here, look here. I mean, it is given here in terms of how say pressure, velocity, whatever. But those are the two dependencies. This is 1 over r squared, and this one over r to the third degree. We have here kind of, if you take difference, for example, you see kind of discriminatory characteristics. You see some kind of mechanism of oscillation. You know, this is very important. That's actually something that I have come from totally different perspective, from the phenomenological concept of orbital motion as in terms of the solar system, for example, as kind of dynamical equilibrium between attractive gravitational force and the repulsive thermal force. And the later one is actually turned out to be 1 over r to the third. So there seems to be consistency, unity, kind of upfront unification, at least as it comes to the natures and forms of those forms as attractive and repulsive. Of course, both of them can be plus and minus. And apparently, that is something that is missing. For example, Lucas, as Roger Ryden mentioned in some email this morning or whatever, some problem exactly with the helium atom that has not been clarified completely, and it will be very important. We will see later. So, okay, I skipped that part. Here is the part related to the formation and structure of neutron. Actually, not to talk too much here, not to lose too much time, it is actually out that the, you know, generally, you know, in the how say mechanics or dynamics of gases, if you have one structure as a toroidal vortex, immediately it induces a complementary movement of the same form. So, for example, here, if you have two, say, maybe with the protons, I mean, it might be some process that may need, how say, some particular conditions as maybe exist in the centers of galaxies and so on. But that happens actually in the electromagnetic wave propagation, generation. But here, if two protons are come close to each other, the only possibility to have a how say, stable structure is for them to actually start, how say, change their position, whatever, so that they actually come into the situation where the flows are co-directional. And then that mechanisms, those mechanisms I explained here, really I will not go at this moment to them. But it turns actually out that around one of them, one of two protons, gets, how say, formed the so-called boundary layer, the, how say, spherical or kind of toroidal circulation of the gas molecules, so that actually the motion that goes around the equatorial part gets kind of neutralized. So that movement cannot impact environment. So that particle then is perceived as electrically neutral, while still the motion that correspond to the kind of toroidal part are present. So here we have kind of situation that one of them becomes electrically neutral, the one still have electrical, how say, charge. And the charge, actually, the sense or sign of the charge is related to the kind of exactly just direction of movement, direction of flow. It is clockwise, counterclockwise, or clockwise. Or here, the toroidal, again, if it is going from the center up or the other directions. Okay, again, I mean, clockwise or counterclockwise, if you look in that, how to say, sense. It's very important thing. So, No, I think I will go directly now to this part that is related to the kind of. Okay. After exposing this all this about proton and neutron, the author actually goes on with the combinations or stable combinational configurations of those, say, nucleons, right? Nucleons. And here talks about 4 of them. You will recognize them. This is the deuterium, what is kind of tritium, or then helium-3 and helium-4. I'm not that familiar with all those, kind of have to get back to the chemistry and other things. But he goes then step by step to how say suggest the structures of, for all of them. So we have here the proton and neutron as individual particles, and then when those of two are come close to each other, they actually have counter-directional flows around the say ring-like flows are counter-directed, so they get attracted to each other. Their magnetic spins are of different signs. Then, if one more neutron is added to them, we have this structure. This is kind of what is this? Thorium or tritium? I don't know. Helium-3 comes in this form, and the alpha particle is like here. So this kind of vertical cross section, and here is the horizontal one. It turns actually out that the most stable configurations are those which have as more as possible of common flows. Like here now, the ether or gas or whatever goes into, gets out, and here in and out. And somehow there is a lot of argument here indicating and explaining why this is maybe very basic, most basic structure, and why later on it is shown why it actually is part of all of those atom nucleus that are related to those magic numbers. And last Saturday, actually, it was you, Franklin, that mentioned that apparently that you have noticed that actually should be something related to that very basic alpha particle and its presence in the atoms that are denoted as a kind of magic number atoms. He goes here, I mean, with really kind of all details that go to other elements, considering addition of everything happens then actually with adjoining or attaching of more protons, more neutrons, and all those, like here, for example, here. Here for beryllium 94, beryllium 995, and so on. So alpha particle, neutron, alpha particle, proton. But the difference is difference between these two atoms or nuclei, for example. So I translated part of it just for some of you to be able to follow. If something is still missing, then I could look back into the book and then come up. But I think almost everything is covered here. But now there is also some argumentation and so on. How, I mean, what happens if you have, I mean, with the how say, nuclei with relatively high number of nucleons, how they get structured actually. You know, somehow there are some against some groups of them that kind of naturally and dynamically stably actually combine to more complex compounds. And I think here is the actually end of this chapter 6. Before maybe we may go to the chapter 7 that deals with the electron clouds, electron shells, and then formation of say elements in later molecules. I may ask you for maybe some questions or some. If you may want some clarification.
So Slobodan, I've been trying to just kind of summarize what you've been talking about. So let me just share you that. Let's see whether I've
Yes.
got what you're saying represented at least at a high level. So let's see here. So, okay, so here's our notes for today. So we have your name here, and this is your email address. So some people have been asking about where can they get a copy of your papers. Now you did send them around to the big email list, but they can also email you, or you can email me. These papers are not actually on the internet on a link, right? They're only your. They have to ask you for it, right?
Yeah. Okay. Yes. I've been sending partial translations of a number of other chapters earlier, so it could be tracked by looking into the emails that I was sending to the group.
Are you going to post these papers somewhere publicly, like Vixera or something like that?
I also have say formed one directory that also had sent a link to it. So now, if you suggest, I could then collect all of them into that maybe same directory and then share the link. I don't think I would have problem with the author because at the time when I was dealing with kind of electromagnetic framework, I asked him if I could translate the related part and put it as attachment in the paper that I presented last year in France at a conference on, I don't know, radio, whatever. So he has just, I mean, he was just fine with that. I mean, so he is just kind of partial translations and so on. If we come to really full translation, then of course I would, or whoever would be interested, would ask for permission or kind of cooperation of the author. The author is pretty aged of today. Maybe he is in his maybe 86, 87 now.
All
So
right. Well, like I said, if anyone wants to get a copy of the papers, they can email you or they can email
yes,
in. So,
sure.
and you translated this book as Aetherodyamics Aetherodyamics.
Yeah,
So we have.
if somebody could, I mean, I would be, how say, also, how say, thankful if people would read those partial translations and then maybe put suggestions there. I sometimes I have maybe too many options, you know, different synonyms or maybe some terms or whatever. It would be helpful if, in particular, if we would go towards translating all the book, and which I think it would be very important and very, very.
So based on what you said, these are kind of the main things I got out of it. So it seemed like the main structural component is protons. So everything is like the main statement is like 99% of like everything we see is actually protons,
Yeah.
and that protons are like a toroidal flow of he calls these particles amers, which I
Yes.
guess is the ultimate ether particle. And even neutrons are like protons, except that they just basically flowing in a different direction.
There is boundary layer around it. Boundary layer of that fluid that actually neutralizes the equatorial or ring-like movement that actually is perceived and experienced as electrical field, so that it becomes electrically neutral.
So a neutron is basically a proton wrapped with this other flow around it.
Yes.
But together, the neutrons and protons basically flow in the opposite directions, and so that's what creates an attraction between them.
Equatorial, yes, equatorial. Yeah.
Equatorial, because like the toroidal is a flow like a donut, like in and out, but equatorial would be like around the equator, right? So there's actually these two different kind of flows going on at the same time. And so you showed like the helium atom, and so that is just like a alternating neutron proton kind of arrangement. So that's what I basically got. So it looks like Harry has raised his flag. Do you have a question, Harry?
Well, I have two points. One is I'm not receiving any of these emails, so I would like it if you would include me on the list. And the other thing is I noticed that at the beginning of the presentation, there was some reference to galaxies and work done at observatory in Russia. Can you explain that a little? I'm not really sure what the relevance is to. I mean, I guess I'm a little bit confused as to how you would talk about observing galaxies and how that relates to particle physics.
He actually comes out of the kind of insights and the experiments within the conventional fluid dynamics and kind of gas dynamics. And then when he looks into the potential ways for such structures to be created or formed, then he, for some reason, I'm not sure, I mean, he starts from the galactical centers and so on, which is not that kind of strange. I don't know. He may not, first of all, this is for the kind of newest edition of the book. In the earliest book, I don't think he had, I'm not sure he had it. But still.
Okay, wait a minute. Let's go back here to the statement. I saw it just a minute ago. Well, it says, as shown below, the ether flows. Okay, let's go up more. Observations at the Bayurakan Observatory. And I think that's referring to.
Yes, there might be something relatively. I don't know what is the at what time it was, but apparently he did not know about findings that outside, out of the centers of galaxies, out of those accretion disks, we have a kind of radiation detected. You know, and there has been a lot of.
I think this is a reference to Armbart Sumyan. Do you know who I'm talking about? Famous astronomer of the Bayurakan Observatory. I'm not sure if I pronounced his name correctly.
There might be a name of the
okay, so he came up with this theory of activity in the nucleus of a spiral galaxy, outflow. Okay, so my question sort of is this theory making an inference that ether is something is being created in these galaxies? Is that what the inference is here?
Yes, here. But I think myself, I would go further. Actually, I was pretty impressed by some insights of some people in the US. I mean, the John Majewski or Milewski, he's Bulgarian actually. This guy, kind of some other people, that John Newman and so, that actually those particles, the ether particles, would be actually coming out of those galaxies. And recently, some radiation has been confirmed. And I would be having different views here. I would expect those protons being squeezed and coming out as kind of elongated vortexes, which could be then interpreted as a magnetic monopoles.
Okay, let's can we back up a little bit and because this is kind of what is more of an interest to me, as opposed to the Big Bang theory, which says that there was this Big Bang and all of the matter in the universe was created at this Big Bang event, whatever that is, which was hypothetical to a certain extent. This particular theory is sort of based on the idea that matter is being created in the nuclei of galaxies and that the matter creation process is observable in our own time, and so it is not an unobservable hypothetical event. Does that sound right?
My understanding, combined with my insights, actually would be that we should not have had one Big Bang, but very many small, relatively small Big bangs. So actually, the spontaneous formation of those structures should be possible without those, conditions. The massive production of them might be related to it. But generally, if you have a, the flow of particles that are kind of elongated toruses, magnetic monopoles, then in their collision, naturally, precessions happen so that actually they tend to form the toroidal structures. It can be shown by Navier-Stokes equations and so on and so on. So, more than that, actually, one could think of and understand that might kind of, again, something that I occasionally convey to the group, that actually would have here something kind of grand recycling. So building matter or building elements, basic building elements, comes out of those highest sized structures. The process of really compression of the structures, emission or radiation back around. So and okay, maybe later we may address that. Maybe
that to me
philosophical and mathematical terms, but now, okay.
That sounds to me kind of like the mainstream idea that stars explode and then the debris from the supernova sort of
please. It's not exploding. It's kind of really process of compression, kind of really kind of like in the how say when corn is grinded, in the mills.
Okay.
It's not like it's more kind of imploding than exploding, and all the time it's kind of really counterpart of the explosion, implosion, and maybe something more important and relevant, I guess, for everything. But anyway, I guess. But may I ask you something now? Do you know for these results from Russia about those emissions, radiations, or?
I'm familiar with the Armbart-Simeon theory. It's not. I don't know. It's sort of not really well known here in the United States, although it's sort of been, mainstream is not really paying much attention to it. They're completely focused on the Big Bang theory and the idea that primordial matter was created in the Big Bang, and then stars formed by some kind of condensation, and then the heavier elements get synthesized in the stars, and then you have supernova that recycle the material that's synthesized, and you create the heavy elements in the supernova explosions, and then that gets swept back up into the black hole at the center of the galaxy and sort of recycled, so to speak. So that explains the origin of the elements, according to the mainstream theory, but there's so many problematical issues with that it doesn't really seem that credible to me.
Yeah.
This idea of Armbart-Simeon is actually, in my opinion, more interesting, but it doesn't fit into the paradigm of the Big Bang, which mainstream is pretty much locked into right now.
Yeah. Okay. Here regarding the protons, actually, yeah, how say suggestion or kind of statement of this author Atsukovsky is actually that proton cannot be found of different origin, and somehow kind of he's suspecting the proper understanding of people who kind of whatever, I don't know, maybe creating or whatever. And how I say, very important is here that this structure of proton has very long duration on what was it, tens, 20 billions of years. And on the other hand,
well, my question is, how is it they have such stability? I mean,
yeah,
I mean, your question might be, why is the
I will tell
proton
you, because
stable and the neutron isn't?
Because of very high speed. It's amazingly how high speeds turn out to be in those layers around the proton and
but if it's so high speed, I would expect it to fall apart even faster.
10 to 23 10 to 23 meters per second. You know,
You got something that's moving that fast, it would fall apart in a microsecond.
No. But you have to go into the, those guys who have maybe basics in fluid dynamics. You may acquire the things very quickly and understanding. It took me a lot of time somehow, but
I think the fluid dynamics guys would agree with me that anything flowing that fast, centrifugal forces itself would rip it apart.
But look, if you in the friction, the velocities, gradients, and everything, you will see how things like that. The friction reduces with the reduction of temperature. Temperature reduces with the increase of density, and it's really kind of not that easy to get into it for us who are not fluid dynamics, but very soon one gets kind of impression that it's very consistent. And when you look into these paragraphs where particular things are explained, then one really can have such kind of I would say can confirm that. So for all of you, I really propose and suggest to go over those paragraphs that I translated, and then later we can go on. I mean, maybe to clarify something, maybe correct some errors if I made, or maybe translate some other parts.
Well, I mean, I have just like a basic theoretical, objection to the basis. Basically, Artevsky's theory is basically fluid dynamics theory. So therefore, we should apply all the known laws of fluid dynamics to his model. And if a proton
is gas dynamics.
Well, gas dynamics, because we know how those things work. We can create
to differentiate these two things. Very important.
We can create like smoke rings, but smoke rings, you fire it at each other, will tear themselves apart.
Okay,
right?
Franklin. Here, then you have to imagine those smoke rings created inside the smoke under high pressure.
And when I imagine that, I would imagine they're going to, when they collide, will rip each other apart even with more veracity than ever before. I mean, that doesn't maintain, that doesn't add any stability.
Yes, in the air, but in the ether. So gas in the gas. So structure of the gas, structure of the smoke inside the smoke under high pressure. There's a very big difference.
Well, I mean, it still has to obey the same gas laws that we observe in a macrodynamic fashion.
You have gas. You have a media of different scales. So out of particles of medium, kind of gas or fluid or whatever, on certain level, created structures. And those structures, those forms, then become particles for next higher scale. So we get up, from amers to say protons, neutrons. you go to the atoms, to the molecules, to the to the systems like chemical systems, then Earth, Sun, galaxies. This kind of.
But I just wanted to. Do you understand my objection? My objection is that we don't observe these kind of stable structures.
If you take experiments
in any medium that we know of.
Okay, I mean, what does it mean we don't see? We don't want to see. I mean, if we would like to emulate, then I suggest to take whatever some room.
No,
I
just don't think that these toroidal rings can ever be stable.
Under pressure as high as possible, and then affect formation those vortexes inside it, and you'll see what's going to happen. Here's, I mean, in the text, please, I really suggest to go, or maybe we can go particular paragraph, and then for me to point to you, but I don't have it kind of really so that I can just quickly come to it. But in the whole, when you come to the atom, alpha particle or helium atom, helium nucleus of helium, and later helium atom. I mean, at least one have to admit that is pretty or very, very, very appealing or kind of.
Well, now another question I have is that the ether is made out of something called he calls them an emirs, which are apparently really dense. That's like you said, like the proton contains like billions upon billions of almost uncountable 10 to the 131 of these particles, which is just an insane number of particles. I think that exceeds the number of like atoms in the universe. But is there any experimental evidence he presents that anything like that actually exists? I mean, how would we find that? To prove this theory, we would have to prove the existence of that particle.
I mean, such things can be supported only by the consistency of the theory in the whole. So at this point, we're discussing.
No, see, I would disagree. I would say that. I mean, if the only reason why you think that particle exists is based on consistency, and there's no way you can experimentally find that thing. I mean, this is like the strings of string theory, right? It's like
myself, I would rather go around or to on those magnetic monopoles that are actually elongated the vortexes and precession of gyroscopic particles and so on and so on. But this kind of something. But I was surprised a little bit that everything like this comes out just out of the gas mechanics or gas dynamics. But anyway, I mean, really, my intention was here how to offer and to get you interested. And I don't know if Bill Lucas is here or maybe Roger Rydin or whatever. We will see. If they take this and put in their model, they may make pretty of a breakthrough there, because they are.
Well, I think your model is actually, fairly close to Bill Lucas's model, because he also uses these toroidal things, and I've noticed that a lot of people actually gravitate towards this idea of a toroidal ring kind of structure.
Yes, but is
although, like I say, I don't know why, because these things are
consistency, by the way, is necessary but not sufficient. The system has to agree with experiments as well.
It agrees maximally. We'll see later in the second part. I mean, in the second part, really kind of. Okay, actually, in the second part, he has started actually out of the quantum mechanics and those wave equations, and so interpreted them as distributions of density and so on. And then, starting from there, actually, he is coming to very consistent structures and explanations and everything. But here, to get back a little bit just to the Lucas atom, look, from the recent email exchanges, it becomes apparent that Lucas has exactly problem with the alpha particle, with the helium nucleus. And here, actually, those issues have been resolved, in my view. So very good if
Well, why don't we go on to your second paper? And because I'm interested about the electrons, because the word electron has not been mentioned so far in this entire paper. So I'm kind of wondering if protons are the main thing, then what are electrons? Because certainly those exist.
so.
Let's see here. So I'll share your second document here, which is your chapter 7, I believe. Yeah, here we go. Chapter 7. The structure of the electronic shells of atoms and molecules. I think so far, mostly you've been covering, say, nucleus structure.
Yeah, just nucleus, yes.
So how does chemistry happen? And where do we get all of these shells from? And you know, why is it that...
Did you give me control over the scrolling?
I think you have control. I think you just have to click more slowly because there's some lag.
I cannot get to the top.
Here, I'll help you. Let me get to the top. You can click the mouse and drag the bar up. Okay, so back at the top.
Okay, here's a kind of first he kind of summarizes what the proton is. And then what the neutron is then. By the way, the neutron is not stable particle. So actually out of it usually comes out proton, and sometimes proton and electron, but not necessarily electron. Just can go, I mean, kind of, the boundary layer can get dissipated and just what remains is the proton. What we can hear. So same way as around the proton, the kind of the boundary layer gets formed. That happens in those compounds. So actually, he gets back to the proton here and shows 3 stable states of the proton. He shows the how we can, okay, maybe to reduce this. I went the other direction. Maybe could you try to get me to that?
Which page are you trying to get to?
That figure with many plots on it. Before that, yeah.
This one?
Yes. Okay.
May I just ask a very quick question about the translation? You have a lot of slashes like flow slash flux, or perceived slash known, or dense slash heavy, or something.
Somehow wanted
are these alternative words?
No, it's not.
Did the original have, and you didn't know which was the best word, or did the original have both words? I just wasn't clear.
No. The original has just one word in Russian. It was my
You were just trying to get the best word, so you put 2 down.
If you would suggest, I mean.
Okay. I just wanted to know because I wasn't clear.
Yeah, sure. No, definitely. So here I was talking about 3 forms. One is the actual proton, as a vortex that has around it the flow of ether that's pretty much kind of non-confined. I mean, not yet constrained. And then proton with a boundary layer. This is the middle part here. So around the proton, we have this kind of layer of spherical, how say, two-dimensional, say, on the sphere, or what flow of ether, as was the case with the neutron. And then situation with the hydrogen atom. So here we have kind of what the proton inside, and we have the flow of ether around it. Then it can come as a kind of electronic cloud or electronic shell. In Russian, it's kind of a small cloud, kind of oblochka, but you know. So you can now imagine maybe this flow around how it goes. We have two basic layers, one with movement in one direction, inside the other direction, and then kind of four kind maybe of closed flows, all of them creating kind of external structure, some kind of hemisphere or spheres, kind of, how to say, kind of. So that would be something like maybe just to on you to imagine, or something like to visualize. So that would be how the helium. So helium has one proton and one electron, right? And this electron here is not kind of electron as a particle. In principle, electron as a particle, I mean, kind of would be again like a toroidal vortex. If we look at the electron and its charge and so on. So we have here something like that. But somehow when it comes to photon, for example, photon would be just chunk of it, broken out and then reformed into two vortexes that are actually complementary and go along each other. I mean, in a pair or maybe a stream of such. My intention, my ability here would be maybe just kind of really briefly go over it and somehow hint some ideas, some forms, and some reasons. Maybe up to you. It would be to use this translation and maybe to get some better insights, and maybe I will be then really happy to help. I mean, we will learn more, and then we will be better translating particular parts and so on. So here, what we have here? I mean, I don't know this Taylor vortex. I am not familiar with it. This is again some kind of a similar structure with more of these layers, right? So those layers are three-dimensional flows of the form, which cross-section, vertical, say here, cross-section is given here in this figure, for example. In the very center of it is the proton. What we have here.
So how does it possibly have those flows? We don't know of anything that has such complex flow patterns.
Yeah, I mean, kind of energetically, I would say those are the flows when it comes to the compounding of those nuclei, for example. As I said, those are flows that have as many as possible common flows. In energy terms, it would be kind of a minimum of energy. But still, I mean, he is operating with the energy, as in his case in the particle mechanics and the quantum mechanics, as sum of kinetic and potential and so on. I would rather go with the work that needed for certain movement to be done. In particular, when it discusses, is not here in this material and in this book, in the previous one. He has actually two options of combining two protons. One atop of each other, and the other one that is kind of this one that two protons are next to each other, where then it's necessary for that boundary layer around of them to be formed. And actually, when he decides on the second structure, he considers the length of flow. So the length of flow will be indication of the energy involved. And then, in that terms, somehow maybe all these structures could be analyzed in terms of the whatever kind of energy expressed or evaluated through those flows and their lengths. And in my view, when I would be doing this, I would take the 1 over r squared and 1 over r third to the third. The attractive and repulsive forces. But somehow we don't have here kind of those kind of structure where those electrons, for example, would be an additional toroidal vortex around the proton as toroidal vortex. So in that case, maybe that's not easy. But the more the structures of the atoms are becoming complex, then those substructures that come closer to those individual separated electrons or some kind of vortexes that are belonging to them become more visible, more distinguished. Anyway, here we have here the hydrogen atom in different states. Those of you who are familiar with those kind of states and the emissions and everything, these pictures might be telling something. For me, not that much, but very important here is that actually he starts. The first subsection here in this chapter is actually analysis and overview of the methods of quantum mechanics in terms of wave functions, energies, wave functions for composite structures, atoms, molecules, and so on. So he starts from there, and in matching those equations or results, those waves, interpreted as distributions of densities instead of distributions of probabilities, he actually starts putting these structures. So maybe he may have some insights into the energy there and stability, but somehow that still stays with me, something that I would be really kind of scrutinizing. And in particular, regarding these kind of basic structures, basic staticism, static nature of atom, as Bill Lucas have been working with, and I personally have been having kind of reservations toward it. To which extent that has been kind of influenced by quantum mechanics and their methodologies and their results, their wave functions, and so on. I'm not sure. Maybe it has been influenced too much. So maybe different approach may bring different picture. Again, of course, both of them should compete on the dynamic stability in terms of the minimum of energy. But maybe more natural kind of evaluation of energy, I would say. Okay, here I have underlined in the first part also, I have underlined two paragraphs. Actually, those two paragraphs explain those problems, or provide answer to those questions and still unresolved problems in different modeling. In here, in particular, in modeling of Bill Lucas and maybe.
Well, what was the problem? What was the problem with helium?
So here, Bill Lucas did not work on helium. I mean, because doesn't have model. So Bill Lucas is using only electric forces, and as Roger Rydin just mentioned in the email that he sent last night, and I here received it this morning, he said that he had some indication that magnetic force should be involved there. So there's a kind of inability, in general inability to explain what is actually stated here. So you may want all of you maybe to read by yourself here this paragraph, right? And I will read myself and maybe be able to point some important things here.
Was he saying what, that the helium shouldn't be stable, or what was the problem?
So nucleus of the helium atom, in the nucleus of helium atom, there are two antiparallel oriented protons. What corresponds to two hydromechanical helical doublets. You know, these helical doublets, you remember was it last? Yes, last Saturday. One of the participants was Eric Reiter. Do you remember, Franklin?
Yes, Eric. Mm-hmm.
He was talking about his 6-year-long work on the on the helium, on the alpha particle actually, and the effects where those particles separate into two substructures. Do you remember? And something like that. So here we have this situation that we have here two pairs of again kind of apparently again stable structures, but again here. Here are shown two flows of ether surrounding a nucleus of helium, and to it adjoined, attached vortices or vortexes of the electron shell. As can be seen from the figure, both primary and secondary vortices are in an antiparallel orientation relative to each other. Consequently, the magnetic moment and the spin of the helium atom must be equal to zero, which indeed is the case in reality. And actually, I have also in the previous chapter the part where, how to say, this kind of electric neutrality and the moments of helium, which actually kind of doesn't exist, whatever, are actually explained. You know, somehow I'm not familiar with this, how to say, topics here, but you know, I had in mind discussion last time, the exchange of emails, the information that was provided by Roger Rydin in regard to the work of B. Lucas and the joint work. That's actually two underlined paragraphs in these two chapters, or partial translations of those chapters, would be very relevant for that, and maybe general answer to the general problem, if it, as it appears to be existing. Bill Lucas is not here today, or maybe Roger
No, I don't
Wright.
think Bill is not here today.
Yeah. But anyway,
unfortunate.
it will be up to you really to look into it. So let's go maybe a step further. Now we have a different situation, but again, here is that statical aspects here is kind of present, but again, statical conditionally. We may be able to how say look in this how say part here, in this how say element of this compound, to be static in terms that maybe the angle here doesn't change, but it is internally dynamic. And if we would be kind of separating this structure, we would get out of it, we would get one toroidal vortex, out of it one toroidal vortex, out of it one, and so on. You know, this hints to some static aspects, how say on the phenomenological level, or maybe something, but I'm not sure to what extent it has been confirmed by the experiments in quantum mechanics or particle mechanics. You know, so I don't see. Maybe there might be also kind of process of turning of those things around. But you know, in this situation, for this discussion, and maybe in general, this, as it has been shown, looks very consistent and worth looking at. So here's different option than, you know, for different elements. Here's beryllium and so on and so on. I mean, those cross sections here are, how to say, those cross sections here are what, I don't know, horizontal, vertical. At this moment, I cannot.
Well, how is that beryllium different from lithium? I mean, beryllium should have 2 electrons around the outside, but I don't see that in your pictures here.
I don't know. I really. There are different berylliums. There are kind of a number of berylliums, 4 and 5. And
Yeah, but fundamentally, beryllium has 2 electrons around it. Lithium has 1. See, so I just don't see in the picture
okay, then you may
how that describes a beryllium.
you may want really to look into it. I mean, really to check for things like that. So I'm not familiar with these structures, so I would not be able to point anything important here. What I had actually maybe on the structures up to the helium atom or helium nucleus. But helium nucleus is just atom. No, helium. What? No, helium has electrons, right? But nucleus and then here the atom, right? The alpha particle.
Well, you really need to explain, what basic chemistry is. For
Okay.
example, for lithium, that forms chemical compounds with 1 element. Beryllium forms elements with 2.
Okay, we are coming
linearly.
We are coming to the formation of molecules, right? I mean,
yes.
So we have come to the point where we have situation here. 2 kinds of bonds, right? One is the ionic bond, and the other is the covalent bond. So here are considered general, just two basic flows. So the co-directional flows. I mean, co-directional means counter-directional. Counter-directional means, okay, same directional on macro level, right? This is clockwise and this is clockwise, right? But in between, we have counter-clockwise motion or flow. So in that case, gradient of velocity drops and the pressure drops. And those particles then get pushed from the pressure of medium itself, surrounding medium of ether, toward each other. And then in the parts of molecules where these flows of this kind are happening, we have the ionic bonding. In situations where these flows are counter to each other, when you look in terms of clockwise and sorry. Okay, oh no, we have here the same motion, right, in both of them? Okay, so here are two options now. So if they are not pushed too much, or if the other components are kind of affecting such situation that they cannot become kind of so that they can get the common flow, that's ionic. If they get the common flow of ether around substructures, like these 2 structures, what happens here, then it comes out as covalent bond. In terms of energy, then it can be possible, I guess, to be explained. If you look maybe the motion and energy and flow of these 2 and this here. Actually, on the go, actually, he has really covered a lot of things that would interest most of you, in particular those who are in the field, who are really working here and would really quickly recognize, the importance, that maybe ask questions and see maybe that later in the next paragraph you get the answer to that question. So I would maybe just stay there, and here he apparently, of course, goes to the different structure, different compounds, and I really would not be able to how say go to it. Here is something that he mentions at this part that I thought, okay, it would be worthwhile translating. He was talking about this kind of what was that particle that such lepton, right? Lepton here, right? So he provides the explanation of leptons as a result of reaction of 2 molecules, and then when it comes to experiments, he gives here experiment that kind of confirms that. I try to translate part of it. He has some process inside here, has some torsion balance here, and has some kind of here some sensitive material and based on that, he actually confirms that there is such process of the parts that get out from those reactions in this situation can be something as is known as lepton, and as is the case with the photons. There is one document that has shared with you that is related to the formation of photons. It actually turns out to be something that drops out of those electronic shells. And he has a very consistent, I didn't translate that, it stays in Russian here. I mean, I didn't even put it here from the Russian original, but in the original, you will see that there has been a lot of, I'll say, really kind of many things has been covered. As I said, many things that would be interesting of most of you, I guess. So that will be what I thought is kind of basic. Elements, or maybe most important things, just to get an idea about the approach and the results and the relevance for discussions and arriving at maybe.
So I wanted to ask, so what is the logic? You said if you have counter-rotating flows, that somehow creates a region of low pressure, but that seems counterintuitive to me.
Frankly, it was killing me, when I started reading it, I was really puzzled, and it took me time, really. I mean, essentially, it turns out that, as I said, kind of gradient of velocities, kind of, I don't know, maybe some parallel with the I mean, when we look at how airplane flies, the wings, how they shape, we actually have kind of higher velocity on the top of the wing, right? And a smaller, lower velocity down there, right? And we say, everybody knows that. I mean, kind of that when the velocity is higher, the lower is pressure, kind of, and and vice versa, But when we look, it's not maybe that easy to understand. But we look at the gradient, what is the difference of velocity in that region? That happens that kind of how say reduction of pressure.
See, I'm thinking that if you have two particles heading at opposite directions, that you're going to get an increase in pressure. I mean, if I took away the freeway barrier between the two counter motion cars and they all start colliding into each other, I think that would result in an increase in pressure.
We have to consider everything within the medium, So those particles are making that medium. That medium has its own pressure. Somehow, I mean, if somebody would be here from the quantum, which is familiar with quantum, I mean, like fluid mechanics or gas mechanics, he would be just fine with that.
No, I think they would be. I would think they would be have the same objections that I have, which is that none of that is ever going to work.
Okay, you just go. I mean, when you have change in velocity, there is decline of pressure, and vice versa. After
you're using Bernoulli's principle,
exactly that.
assuming that you have a constant
fluid mechanics.
fluid.
Something many people are familiar with. Ask somebody who is from that domain, and please check with him. Thank you.
It looks like Hans has got a question. Go ahead, Hans.
Yeah, I have a remark. I see all those flows and movements, and one thing that quantum dynamics raised at the advance of the last century was the fact that atoms don't emit any kind of energy if they don't change their mode. So if no mode change takes place, then nothing goes in nor comes out. And according to these flows that I saw painted here during this last hour, they all produce energy and emit energy, and that's impossible in a
No,
in
why,
an atom that stays in reality.
so okay, here, okay, as I said, the energy is there. Everything is happening is in a pool of high energy. You know, something that quantum mechanics is kind of just fine with, but somehow, kind of structuring and so on, maybe looking at such a medium not in such a way that it can be structured and so on and so on. But here, there is a source of energy. No problem, no fear about whether atom can radiate and not stay stable. That really, there is no need, there is no reason for such that. Once atom radiates, part of it gets out, it gets compensated, gets how say replenished by inflow of particles of ether into the structure, So later, before when I was talking, actually it skipped my memory, my mind. But I wanted to stress actually that in the original, in the part that I did not translate here from this chapter 7, there has been a kind of lot of covering of all those radiation patterns, radiation, how say, diagrams, spectral lines, complex spectral lines, and everything, And he assigned to each of them, or many of them, maybe most of them, if not all of them, the configurations that would be capable of producing such effect. No problem, no fear of energy being lost. Actually, at one point, and it's something that kind of really is something very, very important and kind of far-reaching, the proton comes out as an elementary engine, motor. It actually kind of, has as a fact a situation where the flow goes out of it and into it and around it, something kind of engine. Out of what? Out of the pressure, out of that situation, out of that structuring. The structuring comes out of that pressure and the features of those particles, viscosity, compressibility, and so on. If we would go with the particles, which are, as I said before, elongated vortexes, kind of magnetic monopoles, or basically elongated gyroscopic particles, then you would have creation just of that structure spontaneously in terms of their collisions and precessions, and Navier-Stokes equation can cover it. Physics and mathematicians are talking about topologies, and looking at the topologies and flows on topologies and everything. I mean, what we have in nature is kind of destruction of that kind, and you meant kind of really having everything what they have there, or if they would be looking into it, they would be then focusing on relevant topologies. But here, energy is there. It just gets expressed locally, in certain form, so that pressure energy, potential energy, that is kind of unordered flow of, say, some particles, gets into ordered flow, organized flow, creating their structures, going into their structures. Actually, that potential energy goes into kinetic energy of internal motion. The more that motion, becomes visible and kind of expressed, it is related to the increase of density, decrease in temperature, and so on. So we have a situation that temperature of that structure is lower than the temperature of surrounding ether, and still the particles as kind of heat going out of the structure to the medium, at least those particles, that kind of heat is being exchanged. here is direct collision or violation of second law of thermodynamics, or on the other hand, or put it differently, actually, how say, refutation of the second law of thermodynamics for open systems. And there is no system that is not open. In particular, we're looking at the natural systems as atom or galaxy or solar system or whatever. They are open. They are happening, and everything is taking place within the how say bowl, or what is the vessel where gas is contained with high pressure. And we would, if we would like now to look into what is the minimum size scale, maximal scale, then we may want to go into the mathematics and philosophy of infiniteness of what was that guy? I forgot his name. Starts with C. Or maybe even to Descartes. And in general, if somebody, okay.
Cantor, I think you're thinking of, mathematician.
Mathematics, actually, it goes that infiniteness could be explained by kind of considering the elements, algebraic elements, to be kind of units, structures, as are those, how say, formations of toroidal vortexes that happens in ether, and even that guy, his name starts with C, very famous guy. I mean, mathematics, philosophy, and mathematics of infinite. I will recall the name. So actually, if the algebra, how say, mathematics or algebra or whatever would be devised so that it relies on those structures, as Greeks have started with stones, small stones, counting them, putting them next to each other, and so on, then actually we may be losing that kind of obstacle, that the hindrance in conceptual terms. What is the highest dimension or highest length? What is the smallest? What is the smallest number, and so on? Here, as I said, my impression is something that we have kind of grand recycling. That material, even if we would think of at one point that we have no structure, but just movement of those, say, amers or planktons or whatever would be the name for those particles that go with very high speed and collide. It would happen actually spontaneously. They will be having here and then creation of kind of formations, kind of not Big Bang or small bangings, kind of the kind Big Bang is, but kind of small implosions that actually, where the energy, potential energy, gets into structured energy and gets into formation, gets a kind of matter, and this just matter of convention. At which size we would start talking about mass, and mass is pretty kind of how say a problematic concept, because it is kind of homocentric and so on. And maybe when we look into electron, which is accelerated and cannot be accelerated much, is enough so that we say, okay, it is kind of really having mass being increased. Actually, what happens is that we are putting that electron in the particular flow of ether. So the effects are actually reduction of pressures that can be explained, and I offered some translations in that part. But if that electron will be moving within the ether substrate, and somebody will be pushing them in some way, not kind of by putting it to the electric field, it would not be how I say exhibiting increase of mass.
So does anyone else have some questions for Slobodan? I know Akibo is here. I think he's got a question he may want to ask.
I have a question still. The electrons, make spherical harmonic oscillations, are well known. If you scan, for example, Wikipedia for spherical harmonics, you find all these nice figures that are quite different from what I have seen here. So why does
yeah. What is your name? Sorry,
Hans.
spherical harmonics? My name is Hans van Leunen.
Oh, okay, good. So actually, as I said, in the rest of this chapter 7, along the how to say relating the quantum mechanical tools and equations and waves and the effects that are measured and as you said, and these structures actually what is key here is actually that the movement how to say those electron clouds or electron shells when excited in particular are kind of vibrating, right? And then the least energy for vibration is for standing waves. And he actually visualized and uses the standing wave, I would not say oscillating, but oscillation, but vibrations of the surfaces of those electronic shells to relate to the spectral lines, and I would say all those results and insights that you just mentioned. So you know that it is if Franklin would be giving me control over of the screen, then I would put the original, maybe go scroll over it. But you may want to do it by yourself. Apparently, one has to have the Russian alphabet in the world, right? To be seen, just to get some idea, you know. And the translator Yandex translate Yandex that I referred to in one of my emails. I mean, I guess yesterday. It's not that bad. I mean, kind of one could infer some meaning, some information just by copying and pasting text from Russian and get translated to English. Of course, I would be really willing and say happy here to help if some additional information or some additional translation would be needed. But yes, it's really kind of. I was surprised that he has started from quantum mechanics. Because you know, my insight is that quantum mechanics has been established, funded because of problems with the Newtonian orbital dynamics. You know, and still I see here rooms for some kind of modification of this very basic configuration that Atsukovsky came up with. To what extent it has been influenced by quantum mechanics, so that he produced those very basic results, essentially all of them. And maybe to what extent there be some problems there that should be needing some additional modifications. I don't know, but I still think there will be something more than just I don't know. To what extent really the measurements are obeying the nature of modeling of orbital motion on atom level as a potential as a non-conservative system. You know, a system that doesn't do any work, and people get concerned if atom radiates, how come? I mean, its energy stays later as it was before. You know. Okay.
So I was curious. So I mean, we're looking at like the structure of the lithium atom here, and it looks like the electron is just a flow around the atom core. I mean, what is the scale that we're looking at here? Does this theory ascribe to the tiny nucleus theory, where we're expecting the nucleus to be the tiny little speck in the middle of the atom, and the electron being this far-flung thing flying around the outside, or is this more like my own theory, where the nucleus is large?
I don't think it's up to size. How to say it's kind of up. It's like how to say. I mean,
is the nucleus? What's the size of the nucleus in this theory? Is it tiny?
There are data all the time along the text. There are information about sizes, starting from proton and then later.
Well, is it tiny or is it large? What is it?
If you put me on the previous, on the, how say, the 10 proton is 10 to minus 23 meter. Not here, but the other document, the chapter 6.
So you have a chart of elements in
So,
here.
to get back to this helium or alpha particle, what is the relationship between the sizes? Are those pictures really up to scale, up to the scale? I mean, maybe they are not up to scale, you know. So if they are not up to scale, you will have, no matter if they're up to scale or up to scale, those flows are actually indicated flows, are actually cross section of the kind of vortex, toroidal vortex. Once it gets out, released from the nucleus, then actually he gets shaped as really kind of toroidal vortex. How far it is from the centrum and so on. I mean, here I really suggest, I would maybe send an email to Bill or maybe to Roger Rydin, if they would take their model and just add the magnetic force as 1 over r to the third degree, to the r to the third degree, not 2 second, but 2, 3. Then they may be getting maybe much better results, because they have problems when they go to the more complex structures, more complex atoms. Then they have to do some averaging, some fitting, and so on and so on. Maybe here, in terms of orbital dynamics, as we have it here visible on macro scale, there may be that model, but just having attraction, repulsion of both 1 over r to the second and 1 over r to the third degree would be making quite a big advancement, I think.
Well, I mean, I don't understand how you can explain the long range electromagnetic force between, say, an electron, a widely spaced electron, and proton. Because if we're talking about fluid dynamics here, if I have a rotating vortex, I mean,
vortex is not coming. Sorry, frankly, vortex is not rotating.
Well, it's toroidal. Okay.
Flow is such that if we look into it, we see that flow, and maybe we can kind of say, okay, this is rotating. I mean, we say the Earth is rotating, but the Earth is actually one toroidal vortex with a very compressed core. So we see the core, we see the Earth, the humus, the bottom.
But I don't see how anything spinning.
But we don't see the magnetic field, the electric field around it, and those fields are actually flows, the continuations of flows of toroidal type form that are part of all those elements from which particular body like Earth is.
But those can't be long range. I mean, the electromagnetic force has infinite range, which means like the electron that's sitting in my body is affecting the electrons that are in the moon. If it's actually a flow, that there's no way any flow happening in my body is going to reach the moon.
Okay, I mean,
it's very short range.
How do you know? Why would you like or think to be attached to the moon that strongly? I mean, if you look,
because we believe that is that we don't see any limit in the range of electrostatic force.
Why you,
not unless you claim that there isn't. I mean, you can claim that there isn't, that there is no interaction between me and the moon. But
if you have the particular flow, for example, on the proton, within, or as I said, not on the proton, but within the structure of proton, that is perceived as electric field, that's ring-like movement, is distributed. It decays with distance and decays as 1 over r to the squared on macro level.
It does not decay 1 over r to the squared. That's definitely wrong.
You are talking
any fluid dynamics would show you that.
Now you, as other people, Roger Harding is insisting that there are no electromagnetic waves, there are only photons. Actually, the point is that the photons are just toroidal pairs of toroidal vortices that are that get how say broken off the electronic cloud. So they go in pair, and their structures is such that it's only very tiny, how say, relatively tiny core, but dense and very large body with the low density. On the other hand, the electromagnetic waves and the transversal actually say mechanism and its propagation has only commonality with light in velocity. Otherwise, the electromagnetic waves are actually just induced complementary vortexes by the influence impact of electrons as again toroidal vortexes the more they are free from the atoms, from the structures, so that just change the angle of their axis on average, and that happens just by a very small angle for the technically used magnetic fields of today. So that they actually, just incline a little bit, and then by those more movements, both toroidal and vortex and the ring-like equatorial, they actually induce the toroidal vortexes around them, around the conductor, and the next one induces the next one, and so on and so on. So that radiation is decreasing this way. Photon is kind of particle, he had just moving drops of the structure of the electron vortex, electron cloud, electron shell, and just move as a particle. So it's stable, but still it takes. There's some information in the document that has translated related to that photon section of the book. There are those informations. I was sending it, attaching to my emails, and commenting based on that. But still, that stays unclear. So we have total misunderstanding or lack of understanding, lack of commonality, so that we go from one extreme to the other. So say there is no waves, only particles, and then but the
Now, did Archer?
to explain everything kind of really. So maybe if the photons can go longer, it can be explained based on their structure. As I said, proton is stable, so it takes 10, 20 billion of years for it to dissipate. Neutron dissipates within 2 or 3 hours. And photons also is very long living, but still with the time it starts dissipated, and the redshift apparently might be just as is kind of something that we know as a tiring light. And if that happens in stages, in quantas, would say, as a redshift is appears to be indeed quantized, that we can explain that. I mean, and we can say the universum is expanding, but the photons are kind of getting tired. So. So in that sense of attenuation, there is a big difference between photons and electromagnetic waves. So electromagnetic waves go down, but within electromagnetic waves, we would have also longitudinal and scalar waves. So we should be looking into those structures. The scalar waves becomes kind of really flow of ether, kind of really kind of laminary flow of ether, as the second magnetic field, so-called. And those experiments that guy Miller or whoever was to show that although we have opposed magnetic fields in terms of the Lorentz force and so on, and even if the conductor is put into the cage or put in the pipe, the metallic pipe, and earthed, we still have induction. So we have induction by that flow, by really kind of something totally different from transversal and even longitudinal in the electromagnetic domain. But in the light, we have something like really kind of particle-like movement, and everything can be explained can be explained by that. So my suggestion would be really kind of to the extent that this book would be. I mean, I was looking into many things. I mean, and I didn't look it. It happened by chance that I came across this book, you know. But somehow it was really starting to kind of explain many things, and somehow I found that common thread, and found this really amazing, the presence of those two dependencies of the forces on distance. So now, I mean, we just may really not want to talk about any or think about any fundamental difference between different forces, electric, magnetic, gravitational, anti-gravitational, whatever, you know. Maybe something that really kind of unified and so on. So just it goes about different scales and some
All
of
right. Well, we're getting towards the top of the hour here. So I'll start to summarize. So thank you very much, Slobodan, today for presenting Atsukovsky's Aetherodyamics. You seem to have gone through a lot of work to do the translation, and from what I can see, the translation is pretty good. It looks pretty native English to me, so good job on doing that translation.
Thank you.
And so we have here this particular theory, which is based on flows, primarily toroidal flows of this primordial substance he calls the amers, which are really tiny. So everything in this theory seems to be based around these protons, which are these toroidal flows. And we already summarized most of that stuff in the first half of the presentation. So in the second half, we started looking at the electrons, which appear to be an additional toroidal flow around the atom. He did show some pictures of more complex things like the water molecule, which is oxygen, which has two hydrogens attached to it. And apparently these molecules are the interactions of these outer flows. So I would have liked to have seen like pictures of larger atoms so we could get a better idea of what the specific geometric progression would be. I think it's easy to see what the progression would be. We saw helium as just being an alternating checkerboard of protons and neutrons. But when you get to something as big as, say, uranium, then it's not quite so clear how you would arrange those things in that model. So that would be another area of investigation.
Just a comment, is just related to the atomic and molecular structures and so on, just that part that we covered here, right?
Yep, so keep up the good work, Slobodan. And that is one possible example of an alternate atomic theory. So definitely that's not the same thing as mainstream, where they just cram all the protons and neutrons in there kind of randomly. I think that there's more of a motivation for trying to say what the forces are. So it didn't look like there was any strong force concept in here. It was mostly counter-rotating flows, somehow creating attractions between various particles. So, but I believe that concludes things. You had a closing comment, Slobodan?
Yeah, maybe just to suggest really to get back to those already translated parts of the sections, and here in particular to pay attention for people who are concerned with the explanation and the structure of the helium atom, right? Or with its nucleus, right? Or alpha particle, so-called. Yeah, it's kind of combination of nucleus and electrons, right? Very important. I underlined the related paragraphs in both of these chapters. And as I said, I mean, I think that many, to the extent the people can find support and kind of similarity within findings and results of this approach, would be maybe some basis for us all to converge to something, which I think that to the 99% do be really what this person has accomplished during the last 50 years, starting as electrical engineer. Thank you.
All right. Well, once again, thank you, Slobodan, and that will do it for this week's episode of the Saturday Science Chat. I hope to see you all again next week, same time, same place.
You,